Okay, here we go. The question for today, would you rather A, be completely invisible for one day, or B, be able to fly for a single day? So which of those? Today, I'm going to go with B. I want to be able to fly like a bird. So that's going to be my choice for today. All right, so let's take a look at a few things. So what do we get when we multiply the quantity n plus 3 by the quantity n plus 10? Well, we know we're going to distribute through. We're going to get n squared, 10n, and then the 3 goes through. 3 goes through to the 10, and we get n squared plus 13n plus 30, right? Now, okay, if I do this one, I'm going to tell you I'm going to get an n squared plus 8n plus 12. So the question is, what do we notice about the outside number every time? The outside number every time. Well, in this problem, we got a 30. When we had a 3 and a 10, the outside number was 30. When we had a 2 and a 6, we got a what? 12. So what do we notice about that outside number? That outside number, it appears to be what? The product of those numbers. So you have a 3 and a 10, this outside number every time is going to be where you're doing that 3 times that 10. So if I said the answer to n plus something times n plus something was n squared plus so many n's plus 12, what could the two blanks be, assuming they don't have to be the same number? Notice there are many options. So what could we have in these two blanks? Well, since it created a 12, what could these be? Well, you could have a 4 and a what? 3. That would have created a 12. You could add a 1 and a 12 because those would have created a 12. Who else? A 2 and a 6. Okay? A 2 and a 6. Because these multiply to give you 12, those multiply to give you 12, and 4 and 3 multiply to give you 12. What if my answer to a problem was n squared plus so many n's plus 20? So what could have created a 20? A 1 times 20, a 2 times 10, 3 times nothing, a 4 times 5. Those would have been your options. It would have had to have been one of these. It would have had to have been an n plus 1 times an n plus 20, or an n plus 2 times an n plus 10, or an n plus 4 times an n plus 5. So the outside numbers determine the final number in our answer. Okay, how do we get the middle number? Well, when we looked at it, the middle number was determined by the sum of them. So let's take a look at this guy. Let's factor it. We've done this before in Algebra 1 and in Algebra 2. What we want to do is we want to break it down into its product of two binomials. Well, to do it, we're going to start with our outside number. And we're going to say, hey, I know that to create that 10, I had to have two numbers that multiplied together to give me 10. So I could have had 1 times 10 or 2 times what? 5. Now, so it's either n plus 1 times an n plus 10 or an n plus 2 times an n plus 5. But notice this middle number, ooh, doggy, sorry about that. This middle number here is an 11. Which of these, this guy or that guy, would add up to an 11? It's going to be the 1 and the 10. So this is going to break down to an n plus 1 times an n plus 10. If we want to check it, we have n times n, which is n squared. We're going to have the 1 times the n and the 10 times the n. So the n times 10 is 10n, and then when I have the 1 times the n, that's 1n. And then 1 and 10 together gives you the 10. And notice, when we put these together, it's going to create, that middle term is going to be the sum of these pieces. Let's say we want to factor n squared plus 13n plus 30. Well, the first step is I say, what could have multiplied together to give me 30? I always am going to start with 1 times the number. And then, so I'm starting at the far outside, 1 times 30. Then I say, how about 2 times something? Yeah, 2 times 15. So all the rest of the answers are between 2 and 15. What about 3? Yep, 3 times 10. So I know everything left has to be between 3 and 10. 4 times something? No. 5, yep, 5 times 6. There's nothing left between 5 and 6. So I know that I've listed all the possibilities. So now the middle number will be created by what the sum of these happens to be. Well, the sum of that's 31. That's not working. Sum of that's 17. Sum of that is 13. Those are the numbers we want. So it's going to be the binomial n plus 3 times the binomial n plus 10. And notice that when we do the 3n and the 10n, that's going to give us the 13n. And when we do the 3 times the 10, it's going to give us that 30 that we want at the end. Again, this should not be anything new. We've done this before. So now we're factoring this. Well, I have 20. Multiples of 20. 1 times 20. Now I do 2 times 10. So everything left has to be between 2 and 10. 3 times, nope, nothing. 4, yep, 4 times 5. There's nothing left between 4 and 5, so I know I'm done. The sum of these is 21. Is that what we want? No, we want a 9. 10 and 2, that's an 8. I don't know what I was thinking. 12. Sum of these is 9. That's the one we want. So it's going to be an n plus 4 times an n plus 5. That's what that factors to. Right, what about n squared plus 27n plus 50? All right, same pattern. List out 50. 1 times 50. 2 times 25. 3 times nothing. 4 times nothing. 5 times 10. 6 times nothing. 7, nope. 8, nope. 9, nope. Done. Which of these combines to give you 27? The 2 and the 25. So it's an n plus 2, n plus 25. What if we have to factor this? Well, you have 10. 1 times 10, 2 times 5. The sum of those is 11. Sum of those is 7. None of them is a 9. Therefore, this is not factorable. You can't factor it. It doesn't break down into the product of two binomials. So it can't be done. That's going to happen sometimes. All right, let's look at this one. What's different? You have a subtracting 5 at the end, a negative 5. Well, we still are just going to say, okay, what are the multiples of 5? 1 and 5, and that's it, because it's a prime number. Now, since it's a negative 5, one of these pieces has to be negative. So it was either negative 1 and 5 or a positive 1 and a negative 5. Now, which of those gives you a sum of negative 4? It's going to be those, because 1 plus a negative 5 is negative 4. So it had to be n plus a 1 times an n minus 5. And notice n times n is n squared. N times that would be minus 5n. You then would come to the 1 times n, and then 1 times 5 is going to give you that minus 5 at the end. But these put together will give you that negative 4n that you have right there. All right, what about this? Well, it has 10 at the end, so we're like, okay, 1 and 10, 2 and 5. However, notice that that is plus, so either both these pieces, 1 and 10, are either both positive or they both could be negative. Since this is a negative here, I notice that if I look at the sum of these, I get 11. Some of these, I get a 7, but I need a negative 11. Well, that would work if both pieces were negative, right? Because a negative 1 and a negative 10 gives you a negative 11, which is what you want. So it's an n minus 1 times an n minus 10. And we could check it. N times that n is n squared. N times that 10 is minus 10n. The 1 here is minus 1n. Negative 1 times negative 10 is positive 10. And then the two middle pieces give us what we need. So yes, that is it. And what about this guy? 20. That's a negative 20. So one of them is negative, one is positive. So it could be 1 and 20, 2 times 10, 4 times 5. Now I look at these, and I know one of them is negative and one is positive. So instead of, I imagine what the difference between 1 and 20 is. Because if one of them's negative and one's positive, it's either going to be positive 19 or negative 19. Okay, it's either positive or negative 19. We need a positive 8. Here, difference, I don't know why I said what I said back there. Sorry about that. But let's back up a second. With the 1 and 20, you could have had a negative 1 and a positive 20, or a 1 and a negative 20. Okay, I should have gone through that a little bit slower. Now that would have created, in this case, a positive 19, and here it would have created a negative 19. That's what I mean by saying it's going to create a positive or negative. Okay, I was a little fast there, sorry. On here, 2 and 10, it's either going to create a positive 8 or a negative 8. Well, this is who we want because we want that positive 8, don't we? That's what we want. So to create a positive 8, we're going to put a negative on the 2 and a positive on the 10. So that means we'll have an n minus 2 and an n plus 10. And we can check it. N times n is n squared. N times the 10 is positive 10n. Negative 2 times that's negative 2n. And then negative 20. Putting it together, these middle pieces put together, give us that 8n we want. And then minus 20 at the end. All right, there we have the lesson for today. That should just be a refresher, so the homework should be pretty easy to do. Y'all have a good day.